Hi everyone, Frankie here, and today I'm going to show you how to dissolve copper. Now, copper is actually lower on the reactivity series than hydrogen. It is less reactive than hydrogen, so it will not react with standard everyday acids like hydrochloric acid or sulfuric acid. You're going to need a super strong oxidizing acid to react with copper. In this case, I'll be using nitric acid. Here's our reaction equation. Solid copper reacts with aqueous or dissolved in water nitric acid to form copper nitrate, which will turn a solution blue, liquid water, and nitrogen dioxide, a toxic brown gas. So you're going to need eye protection, you're going to need gloves, and you're going to need respiratory protection when you're performing this reaction. So you're going to need concentrated nitric acid, a beaker to contain the acid in, and copper. So let's go back and observe the reaction.
Alright, so let's drop the copper in now. Here's our nitric acid. It will take a moment to get through the oxide layer on the exterior of the wire, then hopefully our reaction will get started. There, now I'm seeing it start to bubble. Alright, let's speed things up a bit and go get a penny with a bit more surface area. It'll form our gas a lot faster and you'll be able to actually see the nitrogen dioxide in this case. It'll be concentrated enough to start to reflect that brown light. Alright, so I've got my pennies now. Let's drop our pre-1981 penny. This penny is made of pure copper. There, you're starting to see the brown gas. Let's drop another one in. There, now the reaction is a bit more vigorous. We've got more copper, more surface area. And underneath that post-1984 penny, post-1981 penny I dropped in there, we're reaching the zinc on the interior. So there's the gas. Again, this gas will smell just like bleach if your respiratory protection is not working correctly. And that means you need to get out of there, let the reaction proceed, and then return later when you can no longer smell the gas. Yeah, the reaction is very, very slightly exothermic. It won't heat your beaker much, but it will just a little bit. As you can see, it's turned blue from the copper nitrate formed. And most of the gas is staying in the bottom of the beaker because it is more dense than our surrounding atmosphere. So once the reaction is complete, I will remove the pennies and the copper wire and see how much of it dissolved. So you can kind of pour the gas out since it's more dense than the surrounding air. Yeah, now this gas is one of the major reasons we put catalytic converters in our cars. When it reacts with water, it forms nitric acid, which contributes to acid rain. The catalytic converters in our cars are made of platinum, which is a noble metal, and catalyzes the decomposition of this gas into harmless oxygen and nitrogen. Alright, reaction's mostly complete now. I'm going to take this inside, neutralize the acid, and if there's any of our copper left, remove it. Okay, the reaction is complete, and as you can see, the solution has turned a blue-green from the copper nitrate. So, sodium bicarbonate is a base, so it will react with acid to form sodium nitrate and water, which will neutralize the pH of our solution here and cause it to be non-hazardous. So let's add the baking soda. Alright, here's the baking soda. You can easily just buy it at a grocery store. So, let's add it and neutralize the acid. Acid-base reactions are quite bubbly and a bit violent, so I want to add it slowly. Fill a little bit of gas for me. Alright, while we dilute this a bit, we'll make it a bit easier. Add some water. Alright, there we go. It's a lot more dilute now. Keep adding our baking soda. Yeah, this is why baking soda is so useful. It can be used to clean up chemical spills. It can be used in food. Baking soda is this quite wonderful substance, in that it's non-toxic, slightly basic, great cleaning agent. So you're going to want to keep adding this sodium bicarbonate until you don't see any bubbling anymore, and that's going to mean that all the acids neutralized and that the solution has become basic and non-hazardous. So, I'm not sure if you could see earlier when the solution was kind of a clear blue, that there was no copper left at all. It totally dissolved all our copper and our pennies, so all the copper here has become this blue copper nitrate you're seeing in the solution. And by the way, let's see if I can find my copper nitrate bag. This dry copper nitrate is often used in pyrotechnics as a colorant. Since copper burns a blue-green when heated, copper ions, this is used as an oxidizer in fireworks to change the color of the flame. Let's keep neutralizing it.
Now, after you've neutralized all the solution, if you'd like to, you can boil off all the water here, and you'll be left with sodium nitrate and copper nitrate. Alright, so now that there's just a little bit of bubbling in, most of our acid is neutralized, we can safely dispose of this without corroding our pipes and poisoning the water supply. So anyways, hope you guys enjoyed, and I'll see you guys in the next video.